Okay, listen. Pause whatever you're doing for a second, because this question is genuinely unhinged. How did ancient Romans pour the largest concrete dome in human history, with no steel, no rebar, no modern math, no safety manuals, and somehow make it survive earthquakes, invasions, pollution, and almost 2,000 years of time like it's nothing? Because today, if an engineer tried this without reinforcement, they'd be escorted out of the room immediately. And yet the Pantheon is still standing there, silently judging us. This is History of Questions, and today we're answering one of the most brain-melting architectural questions ever asked. How was the Pantheon dome poured without rebar? And why did it collapse? Stay with me, because the answer isn't luck. It's not magic. It's something way more uncomfortable. The reason this question hits so hard is because everything you've been taught about concrete says this structure should not exist. Modern concrete cracks. It fails. It needs steel like bones need calcium. Take the steel away, and everything falls apart. Except here it didn't. The Pantheon dome has no internal metal skeleton hiding inside. It's just concrete and confidence. And that contradiction alone is what keeps engineers awake at night, because it suggests the Romans didn't just stumble into success. They knew exactly what they were doing. Now let's talk about scale, because this is where things stop being impressive and start being offensive. The dome spans over 43 meters across, and to this day, it is still the largest unreinforced concrete dome on Earth. Not ancient Earth, modern Earth. And somehow it gets thinner as it rises, meaning the part that feels like it should be the weakest is actually the lightest. If that feels backwards, good. That's the first sign you're thinking like a modern builder instead of a Roman one. And here's where most people mess up the explanation. They assume Roman concrete is the same concrete we use today. It absolutely is not. Roman concrete was mixed with volcanic ash, lime, and stone in a way that chemically behaves differently over time. Instead of slowly degrading, it actually continues to strengthen, especially when exposed to water. Which means rain doesn't damage the Pantheon. Rain upgrades it. That sentence alone should feel illegal. And now comes the part that really hurts modern pride. The absence of rebar wasn't a weakness, it was a strength. Steel rusts. Steel expands. Steel cracks concrete from the inside. Roman concrete didn't need steel because the structure was designed so almost every force was compression-based. The weight pushes inward and downward, locking everything into place like gravity itself is holding the building together. No tension, no tearing, no slow internal failure. Just physics doing unpaid labor. And once you see that, you realize the Pantheon isn't standing despite gravity. It's standing because of it. The dome presses outward into massive circular walls that are absurdly thick, acting like a stone embrace that refuses to let anything escape. Every block is helping every other block stay alive. This isn't a building, it's a system. If this is already making your brain itch, subscribe to History of Questions. We ask the questions that history quietly hopes you don't. Here's where the Romans quietly flexed harder than anyone expected. They didn't use the same concrete everywhere. At the base of the dome, the material is heavy and dense. As the dome rises, the materials get lighter and lighter. Brick fragments, then volcanic pumice near the top. That means the upper sections weigh dramatically less, reducing stress where stress would normally be fatal. Modern engineers call this optimization. Romans just called it building properly. And those square cutouts inside the dome, the coffers, they're not decoration. They're weight reduction. Each one removes unnecessary mass while keeping structural integrity intact. It's like shaving ounces off a helmet until it's perfectly balanced. Which means Roman builders were actively managing weight thousands of years before calculators existed. That should sit with you for a second. Now let's address the biggest how question of all. How did they pour this thing without it collapsing halfway through? Simple answer: they didn't pour it all at once. The dome was built in horizontal layers, each one allowed to cure before the next was added. Temporary wooden supports held the shape, but because each new layer was lighter than the one below it, the structure never exceeded its own strength. This wasn't reckless. It was controlled patience. If you're still watching, you're officially one of us. Subscribe to History of Questions. We're just getting started. And then there's the oculus, that massive hole at the top that people assume is just aesthetic. It's not. The top of a dome is where tensile stress loves to crack things apart. So the Romans removed it entirely. No crown means no crown failure. Less weight, less tension, more stability. The oculus isn't a flaw, it's a structural cheat code that also lets light and rain inside, which again, helps the concrete grow stronger. Modern scientists still study Roman concrete today because it self-heals. Tiny mineral crystals form inside cracks over time, sealing them naturally. Our concrete doesn't do that. We optimized for speed and cost. Romans optimized for eternity. And now, centuries later, we're reverse engineering their work like students who lost the answer key. If you want more moments where history casually embarrasses the present, subscribe to History of Questions. So how was the Pantheon dome poured without rebar? Because the Romans understood geometry, gravity, materials, and patience deeply enough to design something that didn't need reinforcement. They didn't fight physics. They negotiated with it. Every decision supported the next, and nothing was accidental. The dome isn't surviving on luck. It's surviving on intelligence. And that's the part history never tells you. Human knowledge doesn't move in a straight line. Sometimes we learn. Sometimes we forget. Sometimes we rediscover things that ancient people already mastered. If this question hooked you, subscribe to History of Questions. Because next time, we're asking something just as uncomfortable. Until then, keep questioning history.